Hello everyone, welcome to another video, and today we're going to discuss about a new question called find diameter of a binary tree. So the question suggests, given the root of a binary tree, return the length of the diameter of the tree. The diameter of the binary tree is the length of the longest path between any two nodes in the tree. The path may or may not pass through the root. The length of the path between two nodes is represented by the number of edges between them. So we just have to calculate the longest path between two leaves, from one from left, one from right, and that may or may not include the root. So now let me explain the same on the whiteboard. Okay, now then, let's consider the example given in the question. The root starts with 1, the left node is 2, and the right node is 3, and then left of 2 is 4, and right of 2 is 5. So the longest roots here are 1 starts from 4, starts from here, and going up to 3, and another starts from 5 and going up to 3. So the length of both are correct. But if there is another node like maybe 6 here, so you see that the longest path here will be starting from 6 and going to 3 in this way, right? So the base case here will be, for example, the time we will see null, right? We're gonna return 0, and the time we reach at the node, we have to see, because we need to take the maximum, we have to see which one is the maximum of these two nodes, and we're going to add 1 before returning to its parent node in our backtracking solution. So when it's null, we're going to return 0, and we're going to check if then when we go up, we're going to check which node of the left and right contains the maximum. Then we're going to add 1 and send it up. And the same way, we're going to calculate diameter and keep track of the max length, because the question suggests that the root may or may not be present in the solution. So there can be a case, or there could be a case where this particular node have maximum length without root. So in that particular case, we have to keep track of the max. That is, while doing our backtracking, at the end, our diameter or the variable will contain the max result. So now then, let's implement the same using JavaScript. First thing first, we're gonna create our diameter variable. Let diameter is equals to maybe number negative infinity, so that we can calculate our max. Then we're gonna create our backtracking function. So function calc, it's gonna take our node, and then the first base case will be if not node or node equals null, we have to return 0. First thing first. Then we need to go to left and right. So let left equals to calc dot node dot left, right? And then let right is right equals to calc node dot. Perfect. Now while returning, we have to check what node of left and right has the max value. Then we'll add 1 plus the current root node and send it back, right? So math.max. So we're gonna do like left and right plus one. So this is our basic structure. So it's gonna return it will take the max from left and right and add one and send it up. So that at the end we're gonna get the max value. But since the question suggests the longest root can present anywhere, even excluding the root, so we have to keep track of the diameter. So we can do that here. So diameter equal to math dot max diameter plus left plus right. So at the end, we need to call our method on the root and then return diameter. So this should solve our question. Now let's see, try our test case. Perfect. Now let's try to run the function on Leet code. Run it. Oops, okay, this one. Perfect. Now let me try to submit it, and it passed. So that's the solution. And please consider liking and subscribing the videos. That will encourage me to put more videos like this. And thank you for watching. See you in our next video.